When we're solving for two unknowns and have two systems of equations, there are three ways that we can solve for your two unknowns. One is by graphing, one is by simultaneous equations, by elimination, and the last is by substitution. In today's video, I will show you how to solve simultaneous equations by elimination. Let's say we have these two equations shown. Now, when we're solving simultaneous equations, it's very important that you keep your work neat. So what I'm actually going to do is I'm going to try to align my x's and y's such that they lie in the same column. That helps you to keep track of where everything is. Now, this is especially important when you have more than two equations that you need to solve simultaneously, 3, 4, 5 equations, and so forth. So I'm going to label the equations equation 1 and equation 2. As you notice, I've used Roman numerals for 1 and 2 because it helps me to keep them separate from the equations and the numbers in the equations from each other. While you can label them as with regular numerals, your regular 1s and 2s, I do not recommend doing so, because if you do that, you may end up with, say you labeled it as 1 minus 2. I don't want you to get confused with the numbers in your actual equation and your labels. So let's not do that. So when we're solving equations by elimination, it's as it sounds. We want to eliminate one of our variables. In this case, let's eliminate our y's because we have a plus y and a minus y. To do that, we can add or subtract our equations together. In this case, we're going to add along our columns. So we're going to say equation 1 plus equation 2. So x plus x gives me 2x, and then y minus y gives me 0, equals 21 plus 5 gives me 26. I'm going to call that equation 3. Okay, to solve our x, we're going to take equation 3, divide by 2. So 2x divided by 2 gives me x. And 26 divided by 2 gives me 13. Next, I'm going to substitute x equals 13 into one of my equations here, either equation 1 or equation 2. I'm going to use equation 2 because the numbers are smaller, but it's not going to really make any difference which one you use. So equation, substitute x equals 13 into equation 2. I get, now my x now becomes 13 minus y equals 5. Okay, minus 13 on both sides of my equation. Remember, as always, on each side of the equal sign to keep it balanced. I'm left with negative y equals negative 8. Now, we can change all the signs as long as we change the signs across. It's equivalent to multiply everything by negative 1. So we can say that y equals 8. So your x equals 13 and your y equals 8. Let's try a very similar question, except this time I changed my sign from x minus y equals 5 to x plus y equals 5. What's gonna happen? So if I cannot add down along my column, because if I add it, I get 2x plus 2y equals 26. But let's do a subtraction to try to eliminate my x. So I'm going to say equation 1 minus equation 2. So x minus x gives me 0, and then y minus y also gives me 0, equals 21 minus 5 gives me 16. Therefore, we're saying that 0 equals 16. But we know that 0 can never be equal 16, correct? So our final answer would be that there is no solution. On the graph, what does that mean when there's no solution? So we have the black line, which is x plus y equals 21, and the red line, which is x plus y equals 5. Now, do you see that the lines are parallel? Because they're parallel, they never meet, and therefore there's no intersection point, and therefore there's never any solution. Let's try another one. Now we see here we have a negative 3y and a positive 3y, so if we add our two equations down along the columns, we can eliminate our y. So we can say that equation 1 plus equation 2, so equation 1 plus equation 2, 3x plus 4x gives me 7x, and then negative 3y plus 3y gives me 0. That leaves me with 7x equals 30 plus 19 gives me 49. Divide both sides by 7 to get rid of our 7 in the 7x. That leaves me x equals 7. Okay, we're going to substitute x equals 7 into equation 1. Now, if you look at equation 1, you see that they're all factors of 3. So, actually, what I'm going to do is before I substitute x equals 7 into my equation 1, I'm going to say that I'm going to divide equation 1 by 3. That leaves me 3x divided by 3 gives me x, minus 3y divided by 3 gives me y, and then 30 divided by 3 gives me 10. I'm going to call this equation 3. Now I'm going to substitute x equals 7 into equation 3. So now my x is no longer x, it's now 7 minus y equals 10. So minus 7 on both sides. So that leaves me with negative y equals 3. And again, we can change the signs across. So we get a positive y equals negative 3. And so our solution is x equals 7, y equals negative 3. Let's try this problem. In this case, as you can see, we cannot just add or subtract down our columns to get rid of either my x or my y. So we have to make it such that it's a common factor. Either we're going to make 2x in equation 1 or 2y in equation 2 so that we can add or subtract the two equations. So let's just take equation 1 in this case. You can do it either way. So let's say we have equation 1 times 2. So that gives me 2 times x gives me 2x minus 2y times 2 gives me 4y equals 10 times 2 gives me 20. And I'm going to call that equation 3. Okay. Now we have 2x and 2x, so we can say that we can subtract equation 3 from equation 2. So I'm going to put equation 2 minus equation 3. So just to clarify, I'm just going to put a little minus, and we're going to change the sign so this becomes a little plus, and that becomes a little minus. Like that. Okay, so 2x minus 2x gives me 0. Negative y plus 4y, so 4y minus y gives me 3y equals 11 minus 20 gives me a negative 9. Make sure I have it aligned. Okay. And to keep things clear, I'm going to label this equation 4. Okay. Then I'm going to say we're going to divide equation 4 by 3 because we want to get rid of that 3 in the y. So we're left with y equals negative 3. Now, so we've solved for y. Now we can plug it into equation 1 or equation 2. I'm going to choose equation 1 because the numbers are slightly smaller. Not a whole lot smaller, but we'll just do that. So I'm going to say substitute y equals negative 3 into equation 1. So Equation 1 is x minus 2. Your y now became negative 3 equals 10. Simplify, so we have x plus 6 equals 10. Minus 6 on both sides, and I'm left with x equals 4. So your y equals 3 and your x equals 4. And I just want to reiterate that you want to keep everything neat. If you notice, I have my equal signs all pretty much in the same column. I have my reasoning or explanation all on the side clearly written, and that way we can keep track of everything. And if you make a mistake, especially when you have more equations to solve at once, you can go back and check each step. Otherwise, if you have numbers all over the place on your sheet, it's very, very hard to keep track of what you went wrong along the way. Let's try another one. Again, we don't have an easy elimination. We have to either find or get rid of our x's or our y's, but it's not immediately clear how we do that. So we have to either multiply my equation 2 by 2 to get 4x's, or equation 2 by 3 to get 3y's. So I'm just going to go ahead and multiply equation 2 by 2 so that I get 4x minus 2y equals 14. I'm going to call that equation 3. Okay. Now I'm going to copy and paste equation 1 right under my equation 3 so that we have it nicely aligned. So I can say that equation 3 minus equation 1. So I'm going to have a little minus there. I'm going to change all my signs, so that will be a minus, that will be a plus, that would be a little minus there. So I get 4x minus 4x gives me 0. 3y minus 2y gives me y. And 14 minus 11 gives me 3. Make sure that's aligned. Okay. Next, I'm going to substitute my y equals 3 into, I'm going to substitute it into equation 2 because the numbers are smaller once again. So I have 2x minus my y, which is now 3, equals 7. Plus 3 on both sides, plus 3, plus 3 to get rid of my negative 3 on the left hand side. And I'm left with 2x equals 10. Divide both sides by 2. So I'm left with x equals 5. And that's how we solve that. Now, what if instead of multiplying equation 2 by 2, I multiplied equation 2 by 3 so that I could eliminate my y's? So let's try that instead. Equation 2 times 3. Actually, I'm going to multiply it by a negative 3 so I get a positive 3y there. So equation 2 is this one. So 2 times negative 3 gives me negative 6x plus 3y equals negative 21. And I'm going to call that equation 3. Going to once again copy and paste equation 1 so that I have them in the same column and we can add down our two equations easily. I'm going to say that we're going to do, because we have a plus 3y and a minus 3y now, so I'm going to have equation 3 plus equation 1. So negative 6x plus 4x gives me negative 2x, and then plus 3y minus 3y gives me 0. So I'm left with negative 2x equals negative 21 plus 11 gives me negative 10. And then if I divide both sides by negative 2, because we want to get rid of the negative 2 in the negative 2x, we get x equals 5. And look, if you see, we have x equals 5 in both cases. That's a good sign. And it should be so. Okay? I'm going to substitute x equals 5 into equation 2. Just because, once again, equation 2 has smaller numbers. You can substitute it into equation 1 if you want. It doesn't really matter. So now I have equation 2 is 2. Now x is 5. So I'm going to change my x to 5 minus y equals 7. Okay? That gives me 10 minus y equals 7. Simplified out 2 times 5. Now we're going to minus 10 on both sides. And that leaves me with negative y equals negative 3. And as we did before, we can change the signs across, which leaves me y equals 3. And as you can see, we have x equals 5 and y equals 3, just as the same as the earlier method we did. We should always get the same answer. It shouldn't matter which way we do it. And when you have one equation in the form of x equals or y equals, it's really better to solve it by substitution rather than elimination. So in this case, I'm actually going to label my second equation 1, and you'll see why later on. I'm going to label this equation 1. Okay. Now you notice that all our terms in this equation are factors of 2. They're even numbers. So I can say that I'm going to divide equation 1 by 2. It gives me, or 2x divided by 2 gives me x. 4y divided by 2 gives me 2y. And 42 divided by 2 gives me 21. I'm going to call this equation 2. Now I'm going to rewrite my top equation such that I have x and y on the left side of my equation. So x, now I have a negative y on the right side, so I'm going to plus y on both sides. That gives me x plus y equals 14. And I'm going to call this equation 3. Okay, now we have an x and an x, so I can subtract my two equations. So I'm going to subtract equation 3 from equation 2. So I'm going to say equation 2 minus equation 3. So I'm going to just put a little minus, minus, and minus there. So x minus x gives me 0. 2y minus y gives me 1y. And 21 minus 14 gives me 7. Then I can substitute y equals 7 into pretty much any of my equations. I'm going to substitute it into equation 3. So I have x. Now my y is now equals 7, so I'm going to plus 7 equals 14. Minus 7 on both sides. X equals 14 minus 7 gives me 7. And that's how we solve the equation. Let's try this final example. So we have 3x and 6x, 2y and 4y. So what I'm going to do is I'm going to multiply equation 1 by 2. So 3 times 2 would be 6x. 2y times 2 will give me 4y. And 9 times 2 gives me 18. I'm going to call this equation 3. Now if you notice, if I subtract equation 2 or equation 3 from equation 2, 6x minus 6x gives me 0, 4y minus 4y gives me 0, and 18 minus 18 gives me 0. So I in actual fact get 0 equals 0. What does that mean in mathematical terms? That means I have an infinite number of solutions. Basically, when you get an equation which something equals itself, 1 equals 1, 2 equals 2, 0 equals 0, x equals x, that means it's an infinite number of solutions. Now in the graph, the two lines actually overlap each other. They're actually one and the same. If you can see, 3x plus 2y equals 9 is this line. 6x plus 4y equals 18 is also the same line. So each point on that line lies or intersects with the point on the line below it. And that's how we get an infinite number of solutions. If you like this video, please be sure to like and subscribe to my channel. Please consider supporting me on Patreon. I also offer tutoring services and sell notes, worksheets, lessons with full answer keys online. All links down below. Thank you for joining me. I hope you found this session helpful.